Hey guys, Will here from MachineLovus.com, and I wanted to show you this little interactive visualization I built with NetworkX and Bokeh. And what this is a visualization of US astronauts and their missions and how astronauts are related to each other via their missions. Every month, the subreddit Data is Beautiful has a visualization challenge, and this month was visualizing the information for US astronauts. And so there's this CSV that you can pull from the Data is Beautiful competition site. And from it, what I've done is take the missions, and you can see the missions flown here, parsed out the data for these missions. You can see many astronauts have been on many missions. Taken that information, connected the astronauts with the other astronauts who are on that mission via the name that was located here, and then plotted this network to where you can identify one astronaut and then see how they're connected. And so this is just something I pulled together, and I wanted to show you it. There's still some things I'd like to work out with it, but it's a very powerful display of network dynamics that you can build with Bokeh. So let's Bokeh and NetworkX. So let's get into it and let's go through this project. Okay, let's get into it. So right now I'm running a Jupyter notebook, and it's running here in this terminal down over here. And if you don't know how to run a Jupyter notebook, that might be the first thing to check out. Essentially, after you've pip installed Jupyter, and I'm using, by the way, I'm using Python 3.6, I believe, 3.6 or 3.7. What you'll want to do is you need to pip install Jupyter first of all, and then I'm using, let's just see if this works. Jupyter should be something like this. No. Okay, Jupyter. Okay, so it's Jupyter.version. I am using Jupyter 1.0.0. Okay, so I have a Jupyter notebook running. I've gone to Data is Beautiful and pulled that subreddit and pulled the astronaut CSV. I'm importing pandas and NumPy. These are NumPy or NumPy. These are our typical imports that I work with, that I start off with. So I'm just going to clear this output, just so we're starting fresh here. And so import these two pandas and NumPy, import the CSV, and then let's just take a look at the CSV to start with. Let me back out a little bit. Okay, so you can see you have astronaut selection year, group flights, number of flights, status, military or civilian, gender, if military, include details, date of birth, job, missions flown, cumulative hours of space flight time. And already there's many very beautiful visualizations of this data. I'm not sure I can compete that well, but I thought it was interesting to visualize the network of astronauts. Okay, so I want to see the missions that are in this CSV. We want to plot by missions. So we take a look at the unique value down here of the missions. Okay, so we take a look down here. We see all these different kinds of Mercury, Apollo, Gemini, classic missions. STS has a lot of numbers. I'm not sure exactly what that is. I'm sure I could Google it or go to Wikipedia and find out. Maybe I will at a different time. So there are a lot of different kinds of missions, and you'll notice some astronauts who have multiple missions, right? STS-51D and STS-34. This, let's see, Terrence Wilcott has a number of missions that he's flown. Okay, so what we need to do is parse out these missions first of all, but let's get a list of the columns here. So You'll notice coming in from the CSV, there's some white space that we're going to need to deal with. This can be frustrating. It was definitely frustrating for me working with this to begin with. And maybe one of those pandas gurus can talk about removing some of these white spaces on import. That might be something worthwhile. So you'll notice the number of flights has a white space before and after, which is troublesome. Okay, so I'm importing regex here. It's a common library. It should come with Python. And then for the index and the row, so index, we're not going to use this, but this is the index right here. For the index and row in the data frame iter rows. Now by the way, there's definitely multiple ways of doing this, but it helps. It helped for me to iterate over the rows. First, I convert this row to a string, and then I strip out the white space, and I replace the ands with commas. You'll notice in here that you have Apollo 12 and Skylab 2. We want to add the delimiter instead of an and, put a comma so that we could parse that out. Otherwise, we need sort of a nastier, more complex regex that I don't want to write. And then the new string is splitting, right? We split this long string. So all of these missions become comma delimited, right? STS1, STS7, STS41C, comma, STS41G, comma, STS3, comma, STS51F. And so we split on the comma, split the string, and then we're essentially going to create this new list, all missions for astronauts, right? So this is all missions for all astronauts. And onto that list, we're going to send this information, the astronaut, the selection year, because we might use it later. So why not just have it? And we need to be careful and put in that white space. So 4J in new string. Now you'll notice this is kind of clunky and it's not very efficient. There aren't many rows in our data set. So this is okay, but if we had a bigger set of data, this would be a costly operation. And so big data comes with its own sets of troubles that you don't have to worry about as much when you have smaller data. Okay, so all missions for all astronauts, we're going to make a new data frame. And let's take a look at this all missions data frame that we've collected. And so you'll notice that we have individuals appearing multiple times. What you can do with the data frame.head is say the number of rows that you want, and you could see this Terrence Wilcutt, we've split apart his missions into multiple rows, multiple lines, and that's exactly what the intent was. We wanted one row per mission. Okay, if you wanted to get rid of the astronauts who have not been on a mission, you could pare this data frame down, but I am not going to do that. I sort by the mission just to take a look to make sure that we have, for example, on Apollo 10, you have John Young, Eugene Cernan, Thomas P. Stafford. And so these were the astronauts on Apollo 10. And what I want to do with the network visualization that we're creating here is to associate these astronauts on the Apollo missions with each other, right? So John Young will be associated with Eugene Cernan, Thomas P. Stafford for Apollo 10. And then if this astronaut has been on other missions, he'll show up connected to other astronauts for those other missions, right? And that's how we'll get our network visualization. So here's the hard part now. The hard part is getting a data frame that has this edge, John W. Young, connected to Eugene Cernan, and then also, so John Young connected to this astronaut, and John Young connected to this astronaut, and then Eugene connected to this astronaut, right? Eugene connected to Thomas. And this is going to expand our data frame from a relatively small data frame of 814 rows and 8 columns into something that's a lot bigger. Okay, and so what we're going to need to do here is a very costly operation. I'm going to start running it because reshape. I make another dictionary. I like to make lists of dictionaries and then pass those lists of dictionaries as a data frame because it's very easy to do. It's very easy to make a pandas data frame from a list of dictionaries. But what I came up with, and I encourage you to find a better way to do this, is to iterate again over all of the now all missions data frame and say for I and j, right, for index and observation in the iteros, and then start another iteration, right? So let's start. Here's the code, but let's walk through this up here. What I essentially do is I say for this astronaut, for this row, and then kick off another row, but look ahead, right? Start looking ahead and see if this mission, right, if this astronaut, if this, let's go by mission essentially, and start to make a new dictionary that would connect this. I have name 1 and name 2, right? So this astronaut connected to this astronaut. So walk through this. And so we need to find if John Young is in any other missions besides Apollo 10, and then add them as another row in a dictionary. So that's the idea behind this code. Very costly though, because it's 2 iterations, and you can see it's still spinning on me, and probably will for a little while. Okay, but it's not. If this data set was a little bit bigger, this would be, I'd have to rethink this whole approach. As it is, I can do it. So if the name on J, so the next iteration is K, right? Index row, so J and K. Also, I could probably do this in a way where I had to do 1. I haven't cleaned up this at all, so I encourage you to experiment with it. But anyway, if the astronaut is the same astronaut name, then we're going to pass. We don't want to add that. Else, if the mission is Nan and the astronaut hasn't been on any missions, we're just going to say none for that mission. We're going to have that astronaut be connected to him or herself. And so there are a number of astronauts who have not been on the mission, any missions. And so we're just going to connect them to themselves, and that will be that. Otherwise, if the J mission is equivalent to the K mission, then we have name 1, essentially John, and then Eugene connected to each other. So name 1, name 2, that's how we have John and Eugene connected to each other. And then it goes forward and it picks up Thomas, which was the next one. And then we just say the mission is the mission, right? So this is how we will get a new data frame. A new data frame that I just called NDF. I just call them new data frame from reshape. Okay. And so once that's done, and now it just completed, we have name 1, which is here Eugene Cernan connected to Thomas P. Stafford, Stafford connected to Eugene, Collins Michaels connected to Buzz Aldrin, Neil Armstrong, Collins Michaels, Buzz Aldrin, right? So for each astronaut, you can think of it this way. Eugene is connected to, or let's go with Michael Collins, is connected to Buzz Aldrin and Neil Armstrong. Okay, so now let's get into visualizing this network. Okay, so Michael Collins was the 3rd astronaut in Apollo 11. Okay, so now we need to import network X, and the syntax is just to import it as NX. And then what we can do is do essentially pass it this data frame, which is fantastic. I've updated to the latest network X version, and so I can't use from pandas data frame, which sounds like a really convenient function. It's updated to from pandas edge list. I believe I'm doing this right. The source is name 1, the target is name 2. And what we can do here is essentially draw this network now and visualize it. So this is the out-of-the-box kind of network that we get. So you have a lot of astronauts who are on 1 or no missions. and then a densely packed group of astronauts who are on multiple missions and who are connected to each other. So let's see. So we make, for the purposes of grabbing names and missions, we can get a list of the unique missions, the unique number of astronauts. We can view in NetworkX the degree of astronauts. So this is the degree is how many other nodes they're connected to. So there was a tutorial on NetworkX, and I pulled a lot of these options from there. But a lot of what's going on in this cell is plotting the nodes, drawing the nodes, and then adding different colors for node lists, node colors. You can draw the popular individuals. You can remove the axes because nobody wants the axes, and you put a title on it, right? And so what's nice is you have a lot of different options to draw network visualizations, and then you can plot. We can sort of zoom in more on this network visualizations and see the densely packed and the sort of the popular astronauts, popular being the ones who have been on a larger number of missions than others. And you'd think that, so there are these clusters here off by themselves, and then other astronauts who are all connected to each other. Okay, so now what we're going to do is going to switch over to Bokeh. And what's nice about this is there is sort of boilerplate that you can do. There's example code that you can pick up and then modify. There's a lot of boilerplate. What's nice about this is there's a lot of boilerplate Bokeh code that you can pick up, modify. There's a lot of imports here. We'll get to that. Let me go through line by line here and just talk about what's going on. Tooltips. This is for the hovering aspect of our visualization that we will want to make. Plot is the plot. That's the essential point in Bokeh where we set up our plot. Add a title. We add tools. So these are the tools on the side of a Bokeh plot. Let me just go here quickly. That's this set of tools on the side. There are a number of different tools that you can just get out of the box with Bokeh, which is fantastic. And then this graph renderer is how Bokeh can take a NetworkX graph. So we've set it up in NetworkX, and now we're going to add more of the visualizations, more of the interactivity, more of the cleaner, aesthetically pleasing pieces of it, put it in graph renderer, this thing from NetworkX. So we imported this from models graphs. You could see from NetworkX. We put in the graph we created above. We're going to say that's a spring layout, scale 1, center 0, 0. So essentially defaults. We're going to make the glyph a circle, size 15. We're going to color it spectra 14. We could add a different fill color. The selection glyph on selection, which we do with the box selects tool, we're gonna fill it out with a different color. Okay, when we hover, it's going to be a different color still. Okay, so this is just setting up the glyphs and their colors for multi lines. So now we can manipulate the lines, right? So here we're manipulating the nodes themselves, and here we're manipulating their connections. Okay, so there's a lot of options that we can add with Bokeh to make this interactive. Okay, so then we set our selection and inspection policies. So nodes and linked edges, edges and linked nodes when we select, and then when we inspect. Okay, and then we just can set this right to an HTML file, which we can use to put on the site. And so what we have here is, I've run this again now, and we have this visualization. And so we can highlight in, use this box selects tool to highlight in on groups of individuals, and then use the wheel zoom to actually, go in and take a look. Okay, so I wouldn't say that I'm done with this yet. There's still a lot even for me to learn here. But what we've done is quickly gotten up to speed. We took a data set that we've essentially pulled off Reddit, that we we're made aware of via Reddit, and then used NetworkX and Bokeh to plot it and visualize it. Okay, so have fun exploring this. Like and subscribe. It really helped me out if you do that. We can do more projects. We can inspect more data sets. Let me know in the comments what you think, and talk to you soon.